Right, this is supposed to be a very rough indication of the outline of the metric system. I mean, probably don't need to spend too much on this because you probably know the basic ideas already. Basic units of the meter and gram, and I've taken to spelling the meter as it's pronounced rather than the French way, precisely because that's what it said. That's how it's pronounced, meter. And when you go by a factor of 10 either way, you get these prefixes which you can put on the front of either meter or gram. And then that goes up to a factor of 1,000 either way, and then after that it's another every factor of 1,000 you get a new prefix. So 10 to the power 3 is kilo, but then you go another 1,000, 10 to the power 6 is mega, and so on. I mean, I've got notation here which probably hopefully you're okay with now. 10 to the power 6, 10 to the power minus 2, 10 to the power minus 3, and so on. Well, this goes a bit off. Micro 10 to the minus 6 on the bottom there. Yeah. So I mean, 10 to the power minus 1 is 1 over 10. 10 to the power of minus 2 is 1 over 10 to the power plus 2, which is 1 over 100. And 10 to the power minus 3 is 1 over 10 to the power plus 3, which is 1 over 1,000. Okay, so we have covered that before already. So yeah, you might be asked to conversions between one form and the other. I mean, hopefully you're okay with things like, knowing your converting from kilometers to meters, just a matter of multiplying by 1,000 and so on. And you've got 100 centimeters in a meter and whatever. If you were to go from, say, a centimeter to a kilometer, or say how many centimeters in so many kilometers, then it would be a case of, well, you could either, if you're happy with it, you can do it straight off, but it's sort of 10 to the power 3 to get down to the base unit, and then 10 to the power 2, so that's equal to 10. So there's a factor of 10 to the power 5 to be taken into account, or you could do it 1,000 times 1,000, factor of 1,000 to go from kilometers to meters, and then another factor of 100 to go from centimeters to meters, so that's a factor of 10,000. So I've covered that idea before, you just add the indices. This, I mean, I haven't actually talked about that before, I'm not too sure. This is just intended to be a very basic overview of the mathematics syllabus. So, I mean, I could just mention in passing that when you have a factor of 10 multiplied together, you just end up with a product which has the equal number of zeros as in the one missing. Yeah, so 100,000. Yeah, you have three zeros there, 2 zeros there, so you should have 5 zeros in the product. All right, sorry about that. All right, okay. What I've got down here on the right hand side is the notation you use for the abbreviations. So the abbreviations, it's just one letter or 2 letters, and that's all. There's no S on the end because S stands for seconds. There's no full stop. It's just two letters or 1 letter. I mean, this type of standard, there are deviations. When you go around the world, you do see deviations sometimes from it, but deviations which are not too confusing. And I know, for example, in Spain, you might commonly see something like that, and it's not too hard to recognise that really means a metre. But I think there's things that could be avoided. Kilometres per hour is that like that, okay? Kilometres per hour, just H standing for hour. You get some people who want to extend from the miles per hour, mph, to kph, but I don't think that's recommended. I don't think internationally kph would be fully recognised, whereas this is the international standard, kilometres per hour. And yeah, also internationally, although in Britain they tend to use a 10k to describe a 10k or 10 kilometre race, I mean, to my mind, this should be like this, 10 kilometres. I stand to be corrected, but I don't think there's such a thing as a 10k race internationally. Yeah. So as mathematicians, we should be particularly mindful of the fact that this system was brought was what's the word? I'm trying to think of another word from invented. It was invented by the world-famous mathematicians at the time of the French Revolution, and it's a depressing feature of mathematics that quite a lot of it's very, very old. So that when you get to mathematics of the French Revolution, you're really talking about really advanced stuff that possibly is taught in universities. So it could well be that mathematicians of the French Revolution are not particularly well known publicly, but you just have to take my word that they are. People like Laplace, Lagrange, etc., world-class mathematicians, and they were involved in drawing up this metric system. And just along the way, I could state that they determined that the circumference of the Earth should be 40,000 kilometres. So obviously the Earth is not entirely round, so it's not exactly 40,000 kilometres, but it's near enough. So that's just another extra bit of information you can throw in. Now, how do we, on a day-to-day basis, how do we recognise these lengths? Well, this is an A4. Perhaps if I do it this way, I might get there. And essentially, this is a standard A4 piece of paper anyway. This is 30 centimetres by 21 centimetres. Strictly speaking, it's 29.7 centimetres by 21 centimetres exactly. But 30 by 21 is sufficiently accurate. The actual ratio between the height and the width is √2, which is an irrational number. So that brings us back to what we were talking about very, very early on, the nature of irrational numbers. But anyway, that's a good starting point. It's often said that a fist is 10 centimetres, so you can sort of test that. That's not far off, 10 centimetres, or a widespread hand. My widespread hand is almost exactly 21 centimetres. Often they state it as 23, but obviously it's mine for 21. And smaller sizes, you've got a standard photograph. This is actually postcard size sometimes, but this is A6. This is A4. This is A6. So this size divided into 4. An A4 paper, you just go like that, and that's A5. That's A5, and then you go again. That's A4. Sorry. That's A5, you go again, and that's A6. So this is A6 size, and that's roughly speaking 10 centimetres by 15 centimetres. You can calculate it exactly from being a quarter of 29.7 times 21 if you want, but near enough, 10 times 15 centimetres. Now, again, there's a certain amount of things about the metric system that you don't really need to know for the GCSE exam, but it's useful to know. There's two, when we're talking about more complex units from the metric system, there are two conventions, the CGS and the MKS. Centimetre gram second, or the meter kilogram second. And what this is about is, well, for example, the unit of energy is a joule. Well, this is in the MKS system. The MKS system is the most common system nowadays. And in the MKS system, the unit of energy is the joule, and that is the energy required to push a mass of 1 kilogram through a distance of 1 meter. And the unit of power is watt, and that is the amount of power required to push a mass of 1 kilogram through a distance of 1 meter in 1 second, and so on. So, you've got this concept of the units being derived in multiples of meter, kilogram, and second, and so Now the more modern unit, more modern convention is SI, System International. And the SI takes the MKS system and tweaks it a bit so it's more convenient, if you like. A classic SI, well, I'll spell this here. A classical SI unit is the litre. Again, I'm spelling it L-I-T-E-R. Now, in the MKS system, the unit of volume would need to be the cubic metre, which is rather big. But a litre is more convenient, and a litre is actually sometimes represented as being a decimetre cubed. If it was a cubed, each side would have a length of a decimetre, which is 10 centimetres. So I might ask from there, again, this is assuming you have certain knowledge about volume and so on. How many, given that a side of a cubic litre is 10 centimetres, how many cubic centimetres does a litre contain? And you might know the answer as being 1,000, because it's just 10 times 10 times 10 equals 1,000. Okay. So if we're dealing with centimetres, when we're talking about areas, we'll be talking about centimetres squared, and if we're talking about volumes, it'll be cubic centimetres. Now, conventionally, I'll write that. That's the notation for cubic centimetres. Now, there is in the metric system, there is a relationship between length and weight. And 1 cubic centimetre weighs 1 gram. So a litre will weigh 1,000 grams, which will be 1 kilometre. Which will be 1 kilogram. So a litre of pure distilled water will weigh 1 kilogram. But something like milk or orange juice, it won't differ. So you get if you've got a litre of any liquid like that, that'll give you a clue as to how much a kilogram weighs. Now, I'll just talk about one other thing, which is the hectare. Hectare is 10,000 square meters. Now, I could again ask you, if a hectare is square, what will be the length of its side? And again, many of you will know the answer to this. It'll be 100, because 100 times 100 equals 10. Okay, that's following the rules as before. When you've got a factor of 10, then the product must have a number of zeros equal to the number of zeros in the two original numbers. So 100 times 100 equals 10,000. So a hectare, if it's square, will have a length of 100 metres. That's fairly easy to understand. This attempts to show it here. It says, how large is a hectare? And then it says what I've just said, 100 times 100 equals 10,000 square metres. So it's comparing it with a football pitch. A football pitch is roughly 100 metres long, so if you can consider that that its width is about the same size, then that is roughly, well, that will be a good approximation to how large a hectare is. So essentially, everyone knows what 100 meters is like, surely. So everyone has an idea what a rough idea of how large a hectare is. Just thinking passing, I just missed a little note out here. I've mentioned the CGS here. This is really for historical purposes, really. You might come across a CGS unit, but I mean, they haven't actually been used for decades. So, yeah, it's MKS or the SI units nowadays. Yeah, so one thing just to finish is, if I've got a hectare, which I know can be represented as 100 metres as a square with 100 metres as sides, how many hectares make a square kilometre? I'll give you time to think about that. And again, most of you, don't want to make any prejudgments, many of you will probably work out that it's actually 100. Because if I've got a square kilometre, which is actually arranged as a square, then a square hectare will have sides of 100 metres. So I can put sort of 10 of them along here. I can put 10 along here, and it'll be like a chessboard. A chessboard is 8 by 8, so therefore it's got 64 squares. If this square kilometre has got 10 by 10, then it's got 100 hectares. So one square kilometre equals 100 hectares. All right, thank you.